Essentially, the James Webb Telescope has provided the most precise image of Proxima b in history, uncovering stunning insights into a potential exoplanet. It supports us as we embark on a journey through space in search of the secrets of Proxima b and to find out if it might be the next Earth. We ought to take off into the vast expanse of space, where an unidentified planet exists in the habitable zone of its star. This planet is more than just any ordinary rock. Proxima b is the real thing, found a mere 4.2 light-years from us. This planet is the subject of many mysteries and wonders. Could there be another Earth, with seas and life? But wait, there's more. Proxima Centauri b isn't alone in that system. Around the red dwarf star, it has a companion, Proxima Centauri c. What else might be hiding in that star system? Maybe there's another companion we haven't yet discovered. The mystery continues. Proxima Centauri produces roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there may be water on its surface? Even life? As we explore beyond our own solar system, we encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are endless. Some even have no bounds, untethered to any star, like wandering travelers in space. Among them all, Proxima Centauri b stands out as especially striking and captivating. This planet has a year that lasts only 112 Earth days, and the distance to its star is generally closer than Earth is to the Sun. Indeed, one side of the planet is constantly washed in sunlight, while the other lies in everlasting darkness. Let's look at Proxima Centauri, the star that Proxima b orbits. Proxima Centauri is part of the Alpha Centauri system, which includes 3 stars, Rigil Kentaurus, also known as Alpha Centauri A, Alpha Centauri b, and Proxima Centauri, Alpha Centauri c. These stars form the closest star system to our solar system. The 2 stars Rigil Kentaurus and Alpha Centauri b form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one in the constellation Centaurus and are the 3rd brightest stars in our night sky, with a peak luminosity of less than 2.7. Proxima Centauri, also known as Alpha Centauri c, is a red dwarf M-type star located 21 light-years from the other 2 stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us after the Sun. The name Proxima actually means closest in Latin. It was discovered in 1915 by Scottish astronomer Robert Thorburn Eighton Innes. Despite being our closest celestial neighbor, it is not visible to the naked eye. Its apparent magnitude is 11.13, which is significantly fainter than the human eye's limit of 6.5. Yet this deceitful Proxima Centauri persists, a star that merits investigation. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy generation. Although they don't produce much energy, the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will continue to burn for an additional 4 trillion years. However, the habitability of a red dwarf star remains questionable. One issue is that Proxima Centauri is a flare star, meaning it frequently produces intense explosions. As a low-mass star, its habitable zone is much closer to it than the Sun's, anticipated to be somewhere in the 0.23 to 54 cents range. But it's not as habitable as it might seem. Proxima b is bombarded by intense ultraviolet radiation from its star, stronger than what we receive from the Sun. It's so extreme that even the tiniest particles, hydrogen, nitrogen, and oxygen, can be stripped away. And just because a planet is in the right position doesn't mean it can support life. Proxima b may lack a stable environment for regulating temperature and maintaining a water-friendly surface. Without that, living organisms would be exposed to extreme space weather, making life nearly impossible. So, while Proxima b might appear Earth-like on the surface, it is far from being able to support life. Scientists remain cautious due to the many factors that make it unsuitable. Still, the mission to uncover the truth about Proxima b continues. Some still hold hope. One instrument that has captivated astronomers is the James Webb Telescope. After years of anticipation, it was finally launched in 2018 and may help determine whether life exists on Proxima b. However, as is often the case in science, things are never as simple as they seem. Several adjustments were required to guarantee that the James Webb Telescope delivers accurate images. As Abby Taber, a theoretical Harvard physicist, explains, if Proxima b is a planet that can absorb light from its star, it can also emit it. The James Webb Telescope's infrared capabilities were specifically designed to detect that light. It can capture emissions from the planet's surface and look for patterns that could confirm the presence of an atmosphere, or water. But what if there is an atmosphere, yet it's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life. Ed Turner, an astrophysicist at Princeton University, warns that Proxima b could be like Venus, with a thick, dense atmosphere and extreme surface temperatures that make life impossible. The journey to unravel the mysteries of Proxima b is not without its challenges, but the James Webb Telescope holds promise. With rising costs and increasing pressure from the scientific community, the need to observe planets like Proxima b is critical. The risks are great, but the potential rewards are greater. The opportunity to discover a distant planet's secrets and its potential for life is a pursuit worth chasing. If the exoplanet were habitable, might we visit it one day? It's the exoplanet closest to us, making it even more intriguing. Practically like our backyard. What makes this exploration even more exciting is that Proxima b is roughly the same size as Earth, and its location in the habitable zone suggests it could sustain life. Its proximity also makes it an ideal location for our search. Despite its closeness, reaching it is no easy task. For spacecraft like Voyager 2, it would take 75,000 years. Still, solutions have been proposed, such as solar sails. These ultra-thin sails could propel a spacecraft to the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to stay on course, eliminating the need for fuel. This cutting-edge technology could offer new perspectives on the possibility of living on planets like Proxima b. However, like any ambitious goal, there are limitations. Again, an atmosphere doesn't guarantee life. Proxima b could resemble Venus, with its intense heat and inhospitable atmosphere. But here's something to consider. The James Webb Telescope can detect emissions if they reach a brightness of only 5% of the current daytime side. That may not sound like much, but for a star dimmer than our Sun, it's significant. If Proxima b had advanced civilizations, they might even use reflective orbital mirrors to direct sunlight from the daytime side to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered. They come in all shapes and sizes. Some are massive gas giants, while others closely resemble Earth. One type of exoplanet that has particularly captured scientists' attention is the gas giant. The composition of these planets is comparable. The gas giants in our own solar system, like Jupiter and Saturn. These massive planets may not be habitable themselves, but their moons could hold potential. In fact, scientists are increasingly turning their attention to the icy moons of gas giants, such as Europa, Enceladus, and Titan, which may harbor subsurface oceans beneath their frozen crusts. Could similar moons orbit gas giants in distant star systems? If so, they too might be candidates in the search for extraterrestrial life. In contrast, terrestrial exoplanets, rocky planets similar in composition to Earth, remain the prime targets for habitability studies. Among them, Proxima b still holds a special place. Its size, location, and proximity make it a focal point of intense research. But whether it is truly habitable depends on many interlinked factors: atmosphere, magnetic field, radiation levels, and geologic activity. Some researchers believe Proxima b could have a molten core capable of generating a magnetic field, which would help shield the surface from harmful stellar flares. Others argue that constant radiation from Proxima Centauri would have stripped the atmosphere long ago, leaving a barren and lifeless world. At this point, we simply don't know. That's why missions like those supported by the James Webb Telescope, and future observatories like the Extremely Large Telescope, ELT, are so crucial. They'll enable us to detect biosignatures in distant atmospheres: methane, oxygen, ozone, carbon dioxide, gases that could indicate biological activity. If we were to find even a single sign of organic life on Proxima b or any other exoplanet, it would be one of the most profound discoveries in human history. It would not only change the way we view the universe but also force us to re-evaluate our place within it. And yet, despite all our technological advancements, space exploration remains a journey of patience. It takes decades to build telescopes, plan missions, and analyze data. But every image, every spectrum, every signal brings us one step closer to the truth. The dream of finding life beyond Earth continues to inspire astronomers, physicists, and dreamers alike. Proxima b, with all its challenges and mysteries, represents the best of what space science has to offer, a compelling question without a clear answer. So, we continue to watch, to listen, and to search. Because somewhere out there, maybe just 4.2 light-years away, lies a new Earth, waiting for us to find it. Unlike Saturn and Jupiter, however, some of these behemoths have been named super-Jupiters. They exceed even the largest planet in our solar system. Yet that's not all. There are also hot gas giants, like Jupiter, which are extremely close to their host star. These planets exist in sweltering conditions, with temperatures that could melt metal. Imagine seeing one of these planets up close, with its furious storms and roiling gas. In addition to extreme heat giants, there are also Neptunian exoplanets, with sizes comparable to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets range in size from smaller than our planet to twice its size. There are even super-Earths, with masses greater than twice that of Earth but still lighter than Neptune. One of the most captivating exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth and possesses an estimated mass of 7 Earth masses. Although it is close to its host star, it is still within the habitable zone. Proxima Centauri b isn't alone, it has a companion, Proxima Centauri SE, which is much farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more interesting is the fact that Proxima Centauri appears to be a world of incredible light, possibly due to the presence of a ring system. There's more to uncover in the Proxima Centauri system. In 2019, astronomers detected a shift in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will be called Proxima Centauri d and will be roughly the size of Mercury or Mars. Imagine a life where there are countless stars in the night sky, each with its own distinctive features. The universe is full of orbits, exoplanets, and other surprises. These are just some of them. As fresh discoveries are made, being a space scientist is always an exciting time. While we don't yet have a precise count of all exoplanets, we do know they exist, just as we know the stars that light up the universe. However, exoplanets are not without their challenges. They are often hidden by the glare of their host stars, making them difficult to study. Still, with advancements in technology, direct imaging of exoplanets is now possible, assuming the exoplanet is large enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young and hot enough to be noticeable from Earth. These restrictions limit the number of exoplanets that can be directly imaged, but they offer a fascinating look at the characteristics and composition of these distant worlds. Exoplanets are most commonly found through the changes they induce in their host stars. The gravitational pull of an exoplanet can cause its host star to wobble, and this radial velocity can be observed by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This technique has provided valuable information about exoplanets, including their size, distance, and temperature. Here are a few fun facts. Over 22% of stars like the Sun have Earth-sized planets in their habitable zones. TRAPPIST-1 is home to 7 rocky, water-covered exoplanets. Exoplanets, like those in our solar system, can also have natural satellites known as exomoons. With more than 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets remain undiscovered. NASA's James Webb Space Telescope is unveiling the secrets of the universe, one discovery at a time. This magnificent telescope has been gathering data and taking stunning images, revealing previously unknown wonders. Recently, it made a groundbreaking discovery that will change our understanding of the universe forever. NASA announced that the James Webb Space Telescope has found the first and only conclusive evidence of carbon dioxide in a planet's atmosphere outside our solar system. This discovery offers important insights into the planet's composition and formation, providing a window into the mysteries of the universe. The gas giant planet orbits a Sun-like star 700 light-years away, and this finding marks a significant step forward in the search for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery would provide us with a new perspective on the universe, one we've never seen before, sparking enthusiasm among scientists and astronomers worldwide. But that's not all. The James Webb Space Telescope has also been busy capturing breathtaking images and collecting data about the universe. One example, the young, infrared-emitting object IRAS 110, which illuminates a cool, wispy cloud. Behind the orange spots, the material cloud reveals starlight from far away, obscured by the ice. Webb conducted this remarkable research as part of the Ice Age project, which aims to investigate the genesis of ice, from its formation to its role in frozen comets. And that's still not all. The James Webb Space Telescope has imaged the inner workings of a dusty disk surrounding a nearby red dwarf star, capturing it for the first time at these infrared frequencies. These detailed observations of dusty protoplanetary disks provide crucial insights into how planets form around stars. By analyzing the composition and structure of these disks, scientists can piece together the early stages of planet formation, from grains of cosmic dust clumping together to the birth of entire worlds. One particularly compelling finding from the James Webb Space Telescope involved detecting complex organic molecules, precursors to life, in these regions. This discovery supports the idea that the building blocks of life might be common across the universe, and could potentially exist even in distant star systems. Webb's ability to peer into star-forming regions, far beyond what was previously possible, allows researchers to explore questions that were once purely speculative. How common are Earth-like planets? Could life form in environments drastically different from our own? What conditions are necessary for habitability? The telescope's instruments can detect the faintest traces of water vapor, carbon-based compounds, and other key elements in exoplanet atmospheres. These chemical fingerprints help astronomers determine whether a planet has clouds, oceans, or even weather systems, and perhaps one day, signs of biological activity. Moreover, the Webb telescope has opened a new window into the early universe itself. By observing galaxies as they appeared billions of years ago, just after the Big Bang, scientists are unraveling the story of how the cosmos evolved, from chaotic beginnings to the vast, structured universe we see today. These observations are more than just scientific data, they are profound reminders of our place in the universe. Each image, each spectrum, tells a story of distant worlds, ancient light, and cosmic forces that shape everything we know. And as technology advances, so too will our ability to detect even fainter planets, study even more distant stars, and perhaps, one day, answer the question that has echoed through human history: are we alone? Until then, missions like the James Webb Space Telescope, the Transiting Exoplanet Survey Satellite, TESS, and future explorers like the European Extremely Large Telescope, ELT, will continue to push the boundaries of what we can see and understand. The universe is vast, mysterious, and full of wonders yet to be discovered. And thanks to the scientists, engineers, and dreamers who make missions like Webb possible, we are closer than ever to uncovering its secrets, one star, one planet, one discovery at a time.